This video is about finding the nth term for sequences that are not arithmetic nor geometric. If a sequence is not arithmetic nor geometric, it is quadratic, and the form for it is n squared plus bn plus c. Let's do this example. So we want to find the nth term for this. Remember that the common difference in an arithmetic sequence is a sub 2 minus a sub 1, or a sub 3 minus a sub 2. So we're going to treat this sequence like it's an arithmetic sequence. So this would be 11 minus 5, that is 6, and 21 minus 11, that is 10, and 35 minus 21, that is 14, and 53 minus 35, that is 18. Okay, so to move from the 6 to the 10, we would have added 4, and from the 10 to the 14, we added 4, from the 14 to the 18, we added 4. Okay, so this would be our common difference. To find a from the general form, a equals d divided by 2. This d is the common difference here. Okay, so that would be 4 divided by 2, which is 2. And so our first term, an squared, will just be 2n squared. Okay, now that we have found that term, we're going to our table. Our table, we call this part a sub o, where o is the original terms. Okay, so I have 5, 11, 21, 35, 53. Okay, and this term will come here, so this is 2n squared. So just note that if, let's say you had a 10 here, it would be 10 divided by 2, which is 5, so you would have had 5n squared, that would come here. Okay, so remember that for the first term n is 1, second term n is 2, third term n is 3, and that kind of thing. Okay, so if I put 1 in this for the first term, it would be 1 squared, which is 1 times 2, that is 2. Second term, 2 squared, that's 4 times 2, that is 8. Third term, 3 squared, that is 9 times 2, that is 18. Fourth term, 4 squared, that is 16 times 2, that is 32. Fifth term, 5 squared, that is 25 times 2, that is 50. Okay, now I'm going to call this part here a sub d, where d means the difference between these terms, between these two terms. Okay, so 5 minus 2, that is 3, 11 minus 8, that is 3, 21 minus 18, that is 3, 35 minus 32, that is 3, 53 minus 50, that is 3. Okay, so the common difference, we need to find the common difference now for these in order to find our b value here. So d would be 3 minus 3, which is 0. So this would just be plus 0n. Okay, and since there's no n there and this number continues the same, it's the same number throughout, it would be just plus 3. So essentially your quadratic function is 2n squared plus 3. Let's check it. Remember that for the first term n is 1, so this would be 2 times 1 squared plus 3. 1 squared is 1, 2 times 1 is 2, plus 3, that is 5. This is our first term, and let's verify it over here. Remember the second term n is 2, so this would be 2 times 2 squared plus 3. 2 squared is 4, so that's 2 times 4 plus 3, that is 8, plus 3, that is 11, which is the second term here. So it's verified. Now let's see how we use the calculator for this part now. Alright, so I'm going to call this part here L1. L1, that would be my terms. Okay, so you have first term, second term, third term, and so forth. L2, those are, I'm going to call it original. That's my original data from the sequence. Alright, so I have 1, 2, 3, 4, 5 terms. So it is 1, 2, 3, 4, 5. Alright, and then L2 going to contain the actual data. So it would be 5, 11, 21, 35, 53. Now I'm using a TI-84 Plus. So I hit start, enter. There are some data in my table here. So let's see, I have it 1, 2, 3, 4, 5. You see that? And then I have the 5, 11, 21, 35, 53. I already input that. So I hit start again, come over to calc, scroll down to number 5, which is quadratic because it's quadratic. Hit enter, come down to calculate, and it's showing us that our A value equals 2, or B value equals 0, and our C value equals 3. Okay? So if we put it back in this form, an squared plus bn plus c, this would just give us 2n squared plus 0n plus 3, which is just 2n squared plus 3. This would be the same thing as we got here. Okay? Good. Now let's look at a second example quickly, and we'll go through this one far more quickly for the sake of time. Okay? So again, this would be 9 minus 2, which is 7. It would be 18 minus 9, which is 9. And then 29 minus 18, and that is 11. And 42 minus 29, and that is 13. Okay? So if we move from this, we see that we're going up by 2 each time. Okay? So our common difference in this case is 2. Remember that A equals D divided by 2, so that would be 2 divided by 2, which is 1. So this would be n squared, or if you want to say 1n squared, it's the same thing. Okay? So we're going to our table now. Remember, the table is A sub O, which is the original data. So we have 2 here, 9, 18, 29, 42. Alright, and because we have just n squared here, we're going to keep this part as just n squared. Okay, so when we put 1 in this for the first term, 1 squared is just 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Then this part is A sub D, which is the difference between these two terms. So 2 minus 1 is 1, 9 minus 4 is 5, 18 minus 9 is 9, 29 minus 16, that is 13, and 42 minus 25, that is 17. Okay, so to find, remember this is the form of it, an squared plus bn plus c. So we already know this part. To find this part, now we need to take the common difference for this. So that would be 5 minus 1, which is 4, and then 9 minus 5, which is 4, 13 minus 9, that is 4, and it goes on and on. Okay, so it would be n squared plus, since we have 4 continually, this would be 4n. Now we need to test to find out if we need to add or something or subtract something in order to get this term. So if I say 4n, and if I put a 1 in it for the first term, 4 times 1 is 4. So if I have a 4 here, what must I do to get this thing? I need to subtract a 3, so that would be minus 3. That's your general form there. Okay? And we can test it in our calculator now. Let's test it in our calculator. Or L1, and this is L2. L1, let's see how many terms we have. 1, 2, 3, 4, 5. So again, we would have 1, 2, 3, 4, 5. Okay? And L2 has the actual data, that is 2, 9, 18, 29, 42. So let's do that quickly. Okay, so start, enter, and we clear this data, and then we're going to put in our new data. So that is 1, 2, 3, 4, 5. And then we come over here, that is 2, 9, 18, 29, 42. Okay, then we hit start, come to calc, quadratic, come down to calculate, and we see that our A value equals 1, our B value equals 4, and our C value equals negative 3. So again, if we were to put it in this form, an squared plus bn plus c, that would just be n squared plus 4n minus 3, which is what we got here. Okay, I hope this video shed some clarity on it for you, and have a great day.